so the pure substances, really the only things that you're dealing with, and on that slide, I think it's like 22. Yeah, this is a really nice graphic organizer for you to kind of always refer back to. You know, your pure substances, you only have two options, either pure elements or those elements as have chemically combined into compounds. Because it's a chemical combination, they can only be separated chemically. Now when we go to mixtures, mixtures are just things being put together. So it's like, you know, like Chex Mix in a bowl. We saw that on one of those study jams. If you can see those visible differences within the substance or the mixture, then it's going to be something that is heterogeneously mixed. And if you can see no difference, like it's all the same throughout, then you're dealing with that homogeneous or homogeneous mixture. And that leads us to this idea of solutions. And so solutions are a homogeneous mixture, meaning you can't see any difference. It's our Kool-Aid powder. It's only one phase, because remember, if we have two phases, then that means that there are differences that we can visibly see, making it heterogeneously mixed. And that takes us to slide number 25, which is our first one for today. So a suspension is a heterogeneous mixture that contains solid particles, usually with different densities, that allow them to settle out. This is like our Italian salad dressing. Those chunks of vegetables, the peppers, the onions, the garlic, I don't know what else might be in there, but at least those things for sure, right? Those are solids, and they're floating around in the liquid, which is mostly like oils and other flavorings and things, right? And so you have two phases. You have the solid vegetables, and then you have the liquid oils. And here you can see it's definitely settled out. I'm getting ready to do weathering, erosion, and deposition in 8th grade. And remember our bottle from last year? This is like representing like a creek that's flowing, right? And it carries that sediment with it. Well, this has been settled out. This is a heterogeneous mixture right now, right? Because you can visibly see the differences in that bottle. Actually, my little shelf is gone over here, right there. And so it's the same kind of thing. That's been sitting since last spring, or maybe last February around this time. So it has had lots of time to settle out, and the more dense material is going to be at the bottom, just like it shows here. But you can visibly see a difference. Now, a colloid is a substance that is microscopically dispersed throughout another substance, kind of like fog. Fog is not how we normally have like our surrounding, right? You know, we'll have it here and there, and actually we have had a few foggy mornings over break. But fog is a form of gas, right? It's the, you have those microscopic particles, and then those water droplets condense around them. And so you have your gas, which is your air, and then you have the liquid, which is basically like the fog droplets in a way. And that's why if you walk through fog, and you kind of can feel it, it's that moist, that damp feel, because it's actually moisture. It's actually that liquid. And so I picked this picture for two reasons. One is the obvious one, because of fog. But what kind of bridge is this? Anybody know what it's called? Looks like, I'm not sure exactly, but it looks like it could be the Golden Gate Bridge in San Francisco. But does anybody know what type of bridge that's called? It's actually a suspension bridge. And so we're talking about suspensions, but suspension bridges have like long cables that come down and suspend and hold up the road part of the bridge. So kind of put that in there, 2 for 1. All right, so separating mixtures and using their physical properties. All right, so mixtures are obviously things that are physically combined. They are not chemically combined. So since they are a physical mixture, we can use physical properties to separate them out. So if we stir something like a big pile or a big bowl of stuff with a magnet, some of the things are going to stick to a magnet and some of the things are not going to stick to the magnet. Well, obviously the things that stick to the magnet are magnetic. That separates them into one pile and puts the non-magnetic things and leaves them like where they were. Remember last year when we talked about the electromagnets and at junkyards, how they have the big electromagnet, like, it looks like a big, huge kind of, big slab, and it hangs from like the tractor arm. That is exactly what they use it for. They put it over a pile, flip it on, anything magnetic sticks to it, they move the arm, turn the magnet off, everything that was magnetic drops. Now you have a pile of magnetic things, and what was left was a pile of non-magnetic. And we were actually at our friend's house over New Year's Eve, and we were driving around, and we passed a junkyard, and there was a giant electromagnet sitting right out there by the road. And I wanted to take a picture of it, but we were going too fast, and I couldn't get my phone out in time. I was pretty excited because I was like, that's exactly what we'd been talking about last year, and then I knew we were going to be talking about it this year as well. So you're using the physical property of magnetism. And we're going to do a lab here probably the end of this week, if my timing's right, where you're going to be given a bowl or a container with different items in it. And you're going to have to use some of these different physical properties to separate things out. Because you're going to be able to visibly see differences, but I don't want you just to be able to be like, oh, there's that, there's that, there's that. You're going to have to use and be able to tell me, what physical property did you use to get that thing out of the mixture, right? So if any of the things are magnetic, if you have a magnet that you can use and it can pull the things out, you use magnetism. Oh. All right, centrifuge, and we kind of mentioned this yesterday when I said that blood was a heterogeneous mixture, and you're like, what? Blood looks all the same, right? It should be homogeneous. Well, a centrifuge kind of can prove that this is not the case. A centrifuge is a device that separates a solid from a liquid by spinning tubes in a circle, kind of like a washing machine. It pulls everything kind of out to the side, and basically what it does is it speeds up the settling process. Because when I shake this up, you'll notice, and if you remember from last year, it takes like a good 3 or 4 days, if not more, for it to get separated out. And then it still stays murky for a long time. Like it takes months and months for it to get this clear again. The big stuff will settle out quickly, but that finer stuff takes a while. So a centrifuge basically speeds up that entire process. And it has a little bit more involved than just density, but what it's actually working on is that idea that it's pulling things to the side. And when that happens, it's pulling it to the bottom as well. And so things that are more dense obviously are going to be at the bottom, and then those less dense things are going to be at the top of that suspension or that liquid. Has anybody, and I think it's called, we used to call it the Gravitron. I think it's the zero gravity, like at the fair. Where does it pull you when you get in it? Where are you feeling like sucked to?
Like that.
Yeah, and I see Sean's hands are going like this. You're just kind of like, and it feels like your face is like, right? It's that crazy feeling. I don't even think I could get on that thing without puking anymore. But I used to love it. Like, it just makes you feel so different than you do at any other point. But basically, it's pulling at you, right, against the sides. And so this is kind of the same idea with the centrifuge. So we're going to, we'll take a look at that video in just a second. But this is what the actual, like in a lab, what the machine would look like. But they use this a lot, like for blood work, for even like separating out, like from the blood, they can get even more specific because they have it separated into those different densities and layers. But these are used a lot to separate things that look homogeneously mixed, but really they are heterogeneously mixed. Our blood has solid blood cells in it. And so we have the liquid part of our blood, but then there's also a lot of solid components as well that you wouldn't really, kind of soft solids, but they're still solids. They're going to show like a hand cranked one on this video that we're going to watch, but this is a more common looking one. Right? And so you can see this looks homogeneously mixed, but then you can see the differences once it is spun out. And basically, again, it's just enhancing. It's like using fast forward to get to this point where things are separated out, but they're not technically, you're not letting the time actually have to lapse. You can speed that whole process up quickly. So the property property that's being used here is density. And then filtration, right? This is the removal of a solid from a liquid by the liquid passing through the pores of the filter paper and then the paper trapping the solid. So if you use like this, the traditional type of coffee maker, this is what's happening, right? You put the coffee grounds in the coffee filter, the water percolates or drips through, and it pulls that water through the coffee grounds, and it takes that flavored water, which is the coffee now, into the pot, all right? It lets the water through because the water is small enough to go through the filter paper, the pore, the holes of the filter paper. It does not let the coffee grounds, because if any of you drink coffee and have ever gotten coffee grounds in it, it's pretty nasty, I've heard. I don't drink coffee, but I've heard nasty, right? You don't want those grounds in it. So anytime you're trying to separate things of different size, you can use a filter. Anytime you make macaroni and cheese, you're using filtration, right? You have the colander with the tiny little holes so the water goes through, but your noodles don't. So it's a pretty basic idea. The physical property that's being used is size. So it can be very simple. So the magnetism and the size are very simple and easy to do. The centrifuge separation is a little bit more difficult, just because you have to have the machine, or a lot of time to sit and let things wait. There's other ways that density can be used as well, but we're saying things that have like a lot of fine particles, like the blood or like my little bottle here, you might need to speed that process up. All right, because of my storage issues, I'm going to stop this and do the videos.